Hi guys, today is March 24th and this is our math lesson for today. I know it probably says on your sheet that today we were going to do fractions of a ruler, but I noticed some of our friends saying that they didn't understand or that they were missing parts or missing partial understanding of the lesson that we did yesterday. So today is going to be more of a review of that. So we're going to kind of slow it down a little bit because we can, right? We're going to slow things down and we're going to focus on the area model and the distributive property today. So make sure you take out your math notebook and a pen or pencil, as well as your Bridges workbook, because that's what you're going to need, okay? So as we always do, even though we're not in class, we're going to start with our anchor chart. So I'm going to click on share so you guys can see it better. And let's present view. So remember, if I do the gesture, you do the gesture. And I want to just highlight Janet from Ms. Delgado's class. She wrote a really funny comment on one of her videos. She was saying that because I asked you guys to say things out loud, and then she's been saying it out loud. Her mom's been like, why are you saying things out loud? Yeah, go for it. Do it. The more that we practice saying things out loud, the better. I'll let your parents know on Parent Square and my teacher Facebook that it's good that you guys are practicing the language, okay? So say it with me: multiply, equal groups, number of groups, multiples, group size, factor times factor equals product, equation, commutative property. So we've talked about this a lot before. We know that 4 times 2 is the same as 2 times 4. It doesn't matter the order of the factors, it's still going to give you the same product. Similarly, associative property. It doesn't matter, again, the order of the factors and how we multiply and which factors we put in parentheses and we multiply first. It's still going to give us the same product. So if we do 3 times 2 times 2, remember we said, well, if we multiply 3 times 2 first, that gives us 6. Then we multiply it by 2, that gives us 12 on this side of the equation. And here, if I multiply 2 times 2, it gives me 4. And then I multiply it by 3, and that also gives me 12. So it doesn't matter the order in which you multiply. The word efficiently. And remember, a sentence I always want you to use is I think the product is because array, rows, right, horizontally, columns vertically, decompose, and then our newest addition to our anchor chart, the distributive property. And then let's take a look at our models and strategies as we always do. Some of these are the ones that we really focused on at the beginning of the year, like repeated addition, equal groups, skip counting, and the array model is awesome. Here are the higher level strategies that we're really pushing for towards the end of 3rd grade. Decomposing and distributive property, right? It's the same. It's just that we use a juicier word for decomposing, and decomposing is already a juicy word, but distributive property is like super juicy. So we know the distributive property, we can say 15 times 3 is equivalent or is the same as 10 times 3 plus 5 times 3 because it's an efficient way to multiply, right? And then we have the model that we've been using to support the distributive property to really see it is called the area model. I say, you say, area model. And I did an example one here so you guys could see it. It looks like area, right? It's just that it's the way that we've broken it up or decomposed the area model. So like if we have 13 times 7, I can decompose the 13 into a 10 and a 3 and multiply it by 7. And here I'm using my distributive property, right? Because I said 10 times 7 plus 3 times 7, 10 times 7 is 70, 3 times 7 is 21, which gives me a product of 91. And so we're going to be talking more about this area model throughout our lesson today. So I'm going to go on to our do now. I'm going to read it to you guys, and then you're going to try to solve. So solve for 16 times 7 using the area model below. Use the distributive property to solve efficiently. I've already given you a lot for you to work from or to work on. So I'm going to ask you to pause in a second to write down the whole do now in your notebook. And so you should have 16 times 7 is equivalent to times plus times And then I want you to copy this area model down. And I want you to notice the connection between this distributive property, the way we've set up the equation, and the area model. So pause it now. All right, you're back. You've solved, and you tried solving, which is what we want. And I'm going to stop sharing this screen so I can share my other screen so that I can write on here. Just give me un segundo. Let's see. Yeah, this should be it. All right, here we go. So you really should have written 16 times 7 is the same as, they've already kind of decomposed it for you. I've decomposed it for you already, but I really wanted you to understand why we're plugging in the numbers where we're plugging them in. So if you notice, we have, right, 16 times 7 is the same as, I'm going to type it. I'm going to make this a little bit smaller. 16 times 7 is the same as 10. Right, 10 times, that was weird, sorry. 16 times 7 is the same as 10 times, well, we're multiplying by the factor of 7, right? So I'm gonna write 7, make this smaller. And where do I notice this, right? I'm gonna show you right now. So this is what we're doing. We've decomposed the 16 into a 10 and into a 6 so that we can multiply 10 times 7 and then 7 times 6. And so I'm going to do this again. Now I'm going to multiply it 6. I'm going to add it up here, and then I don't know why that keeps doing that. And then I'm going to multiply it by 7. Okay, so now we should have 16 times 7 is equivalent to 10 times 7 plus 6 times 7. And so let's solve it from now. From this point forward, we're going to solve. So we know 10 times 7, I'm going to write on the side, we know 10 times 7 is 70. And then 6 times 7 is, if you are still doing equal groups for this, we could also decompose it really easily. So let me just do that really quickly. If you don't know what 6 times 7 is yet, if you haven't memorized your multiples of 6 or your multiples of 7, I'm going to grab a marker really quickly. I can just decompose a 7 into a 5 and into a 2, right? And so let me go back to my taping so it's easier. So I can say 6, and let's just use the distributive property so that we can make this even more practice. This more efficient. Make this a little bit smaller so I can fit it better. So 6 times 7 would be the same as, right, 6 times 5 plus 6 times 2. Why? Well, here it is, right? Because we've decomposed a 7 into a 5 and into a 2. So I'm multiplying 6 times 5 and then 6 times 2. Which 6 times 5 gives me a product of 30. And then I'm not gonna forget my addition symbol, and 6 times 2 gives me a product of, what, 12. And so 6 times 7 is 42. So now if I go back here, 6 times 7 then is 42, and I still have to add, 70 and 42, 0 ones plus 2 ones is 2 1. 0 ones plus 2 ones is 2 ones, and then 7 plus 4, or 70 plus 40. I know 70 plus 30 is 100, plus another 10 is 112. So I think, or I believe the product is 112. Give yourselves a double thumbs up if you got a product of 112 for this do now. All right, awesome. So I'm going to stop sharing this screen so I can go back to my Google Slides. 1 second while I do that. Let's see. No, it's not that one. It's this one. Yep. Okay, so we've done our do now, and we're going to continue with some SBAC review. I went on our SBAC website and I was looking at our percentage for this one. This one was about like 48% for my class. I'm not sure about the other two classes. I'm assuming that you guys kind of did similar, or you chose similar responses, because this one was a little hard. We haven't necessarily done this type of question. We've done math very similar to this, but we haven't had this question type before. So I'm gonna read it and then I'm gonna ask you to try to think like, what do you notice? And then to try to solve it on your own, and then we'll do it together. So Addy and Lydia walk to school together. They count the number of blocks they walk in each direction. So here's the direction. If they walk straight, they walk 3 blocks. If they walk to the left, they walk 5 blocks. If they walk to the right, they walk 2 blocks. If they walk to the left, another 3 blocks. The left again, a block. They each use a different method to find the total number of blocks they walk to school. So Addy's solution is 3 plus 5 plus 2 plus 3 plus 1, which is what do you notice, right? Where is she getting these numbers from? And then look at Lydia's solution. Lydia says 3 times 3 plus 5 equals 14. So first of all is what I want you to think to yourself is, what do you notice? What is the similarity between Addy's solution and Lydia's solution? And so I'm going to ask you to write in your math notebook. And I'm going to write on here so you guys can see it. But I think, and let's make this nice and big so you can see it a little bit better. So I think a similarity between Addy's and Lydia's solution is because I'm gonna put this in present so you guys can see it, and I want you to write it down in your math notebook. Like, really look at it closely. What do you notice is the similarity between Addy and Lydia's solution? So I think a similarity between Addy's and Lydia's solution is because and pause me now so you can go do that. All right, so you're back. You should have written, I think a similarity between Addy's and Lydia's solution is that they both have the same answer, right? For Addy, she added all of those numbers together, and so she had a sum of 14. Whereas Lydia, she multiplied and then she added, so it gave us a product of 14 as well. That's interesting. Well, now we're going to look at the question, because it says, which equation shows why they got the same result? And here are the options. I'm going to read it and then we're going to figure out which one to eliminate in a moment. So option A says 2 plus 3 plus 1 equals 3 times 3. And I'm looking at her solution. So 2 plus 3 plus 1, well, 2 plus 3 plus 1, 2 plus 3 is 5, plus 1 is 6. 6 is the same as 3 times 3, 3 equal groups of 3. What do you guys think? Should I keep it or should I eliminate it? Okay, let's look at the second option. It says 3 plus 3 plus 2 plus 1 equals 3 times 3. You know 3 plus 3 is 6, and then 2 plus 1 is 3. Equals 3 times 3. So this would be 3 plus 3 plus another 3, that's 9, and 9 is the same as 3 times 3. Okay, do I keep it? Do I eliminate it? We'll see. Option C, 3 times 3 is 6. So 3 equal groups of 3 is the same as 6. And then option D, 2 plus 3 plus 3 is the same as 3 times 3. So remember, let's add it here. So 3 plus 3 is 6, plus 2 is 8. So 8 is the same as 3 times 3. Now think to yourself which ones I can eliminate, and out loud say it in your home. Like, I think we should eliminate because, and now we're back. Okay, so what I'm gonna do is I'm gonna go to my other screen so I can show you guys. Let's go down a little bit. And I'm about to share once more. And here we go. All right, so let's look at it. I think we could probably immediately eliminate option C, because 3 times 3 we know it gives you a product of 9, so there's no way. And also when we're talking about option A, 2 plus 3 is 5 plus 1 is 6, and 6 is not equivalent to 3 times 3 because we know 3 times 3 is 9. Let's look at option D. 2 plus 3 plus 3 equals 3 times 3. 2 plus 3 is 5 plus another 3 is 8. So 8 is not equal to 3 times 3, so we can eliminate this one. This is me eliminating it. And then let's look at option B, because that's our option that we have left, and let's make sense of it. Like, why does it make sense that Lydia's solution and Addy's solution gave us the same answer? So they wrote 3 plus 3 plus 2 plus 1, right? So 3 plus 3 is 6 plus 2, or 2 plus 1 is 3, so that would give us 9, and 9 is equal to 3 times 3. But let's give ourselves a check mark. But let's kind of zoom in. Let's see if I can zoom in a little bit more. And make this a little bit bigger so you guys can see it. And that's gonna move it a little bit, so just ignore if it looks weird now. But so for Addy's solution, she said 3 plus 5 plus 2 plus 3 plus 1 equals 14. And here it seems she said 3 times 3 plus 5. So she kept the 5. Let me use another color. She kept the 5. So I'm gonna check this off. And it seems like what she did is that she took she saw that there's one 3, a second 3, and then there's not another 3, but there's a 2 and a 1. So she added those together. And so instead of having all of these numbers to add up, 3 plus 5 plus 2 plus 3 plus 1, she noticed that she had 3 equal groups of 3. And then she multiplied 3 times 3 plus 5. Which is the reason why we got the same, or Lydia and Addy got the same answer. In the coming videos, we'll do more examples of this, but this is really good practice for us to notice the similarities between two different strategies. I'm gonna stop share this screen and go back to our other screen so you guys can see. We're gonna continue with the meat of the lesson today. So 1 second while I share again. And here we go. All right, so we're gonna do our learning intentions. I was gonna do fractions of a ruler today, but like I said earlier, I just wanna make sure that we really understand distributive property and the area model. So this is just gonna go a little bit deeper. So remember, repeat after me. Today we're going to sketch arrays for 1 by 2 digit multiplication and represent our arrays with distributive property. With what? Yep, distributive property. Success criteria. I can solve a story problem by sketching an area model and, ooh, I made a big spelling mistake, utilizing, I forgot the Z, utilizing the distributive property. So by the end of it, I really want you to really feel encouraged and feel like very confident in using an area model and using the distributive property to multiply efficiently. Instead of doing like 26 equal groups of 3, because that's gonna take you forever. We want to move away from that. We want to move into more efficient strategies like using an area model and using the distributive property to represent the area model. Language intention. I use words from our anchor chart like distributive property, the area model, factors, and products. And our social intention, as it's been these last few days, I do my work even when no one is looking. So we're going to start with our learning intention, which we said that we're going to sketch arrays for 1 by 2 digit multiplication and represent our arrays with distributive property. So we're going to start with a story problem. There are 8 members in Jamal's band. Each band member needs to sell 23 raffle tickets to raise money for the band to play in a contest. If each member sells 23 tickets, how many tickets will the band have sold in all? I want you to think to yourself, A, what do you notice? B, what equation can we write to represent this problem? I don't want you to solve yet. Remember, it's really about the thinking process. Like, what is it asking you to do? Make a movie in your head as I read the problem. If you need to listen to the problem again, rewind it so you can listen. Okay, so I'm gonna read it one more time. So there are 8 members in Jamal's band. Each band member needs to sell 23 tickets to raise money for the band to play in a contest. If each member sells 23 tickets, how many tickets will the band have sold in all? So I'm going to stop sharing the screen so that we can go to the other screen. 1 second while I do that. Back and forth. I'm going to scroll down so you guys can see it. All right. And let's do it. So you might have noticed, you might have said to yourself, well, it's asking us how many tickets they sold in all. And we have 2 factors that we're working with. We have 23, we have 8 band members, and they each sold 23 raffle tickets. You might have thought to yourself, well, they each sold 23, so that must mean that there's a multiplication equation in there. And you're right, there is a multiplication equation. So we're gonna write our multiplication equation down, and if you did not get it, that's okay. You're doing the work with me. Whatever I'm writing, you're writing too. So 23 times 8 equals, let's do B for, or T for tickets, because we don't know how many tickets in all. So 23 times 8. Let me just make this a little bit smaller so I can fit things. This is a big, darn it. This is a bigger multiplication equation that we're working for, and it makes me think, hey, we should use the distributive property and maybe use an area model to represent this equation. Because I really don't want to spend half an hour doing 23 equal groups of 8. That's going to take me again forever. So what are we going to do? We're going to sketch an area model. Let me see how I'm going to do that. So I have 23 times 8. So I'm thinking we could say 23 times 8 is the same as, I think we should decompose the 23 because that's a larger number. We can say 20 times 8, because if I decompose the 23, I can decompose it into a 20, and then I'm going to decompose it into a 3. So now we have our distributive property represented, but we're going to sketch an area model right now to represent this equation. So 23 times 8 is the same as 20 times 8 plus 3 times 8. Again, I decompose the 20, I'm going to use a marker so you guys can see it. I decompose the 23 into a 20 and into a 3, and I had to multiply it by that factor of 8. So now I'm going to build my area model, and I'm going to try my best to make it look neat. That's kind of hard on here, so be patient. I know I'm going to multiply by 8. This is going to be larger because it is 20. Let's use a rectangle. That's not a very good one. Let's see, where's my rectangle? Let's just try that again. Okay, oh, here's my rectangle. All right, so I'm gonna make this a little bit larger. And then I know I'm gonna add another little piece over here. Okay, so now I'm gonna label this. So I'm gonna go back to my markers. Okay, so I know I'm multiplying, I'm doing 20. I've decomposed the 20 and a 23 into a 20 and into a 3. And I'm multiplying by 8. Okay, so now here's my area model. I've decomposed a 23 into a 20 and a 3, and now I have to multiply 20 times 8 and 3 times 8. Well, I know what 3 times 8 is. We should all know what 8 times 3 is by this point of the year, so we know that's 24. And now 20 times 8. 20 times 8. Let's see. I can count by 20s on my fingers until I get to 8 20s, or I can use my strategy for when I'm multiplying by a multiple of 10. And I can start with, well, I know 8 times 2 is 16. And then if I have a 0, I'm bringing that 0 down, right? So that's really 160. Let me just confirm with my fingers, right? 20, 40, 60, 80, 100, 120, 140, 160. So this is now 160. Now, what am I going to do with these numbers, these products? I'm going to add them. Because here it is, 20 times 8 is 160, and 3 times 8 is 24. And I'm going to use a different color just so you guys can see it better. 0 ones and 4 ones, that's 4. 6 tens and 2 tens, 60 plus 20 is 80. And then I have 100, right? So then our product, or the number of tickets that they sold 184 tickets in total. So let me write that down so you guys can see that. They sold a total of 184 tickets. And I'm gonna make this easier for you to see it because I know you can't see that well. I'm not a fan of what that looks like right now. Okay. All right. So now I'm going to ask you to do the second one on your own. I'm not going to show you the answer today. I'll do it for a review tomorrow in the next video. But you're going to try your very best to use an area model to solve and use the distributive property to solve. So 4 classes of 3rd grade students went to the museum for a field trip. 4 classes of 3rd grade students went to the museum for a field trip. Each class had 27 students. How many 3rd graders went to the museum in all? So I want you to solve this in your notebook. And tomorrow we'll review it to see what the answer was. So I'm going to stop sharing the screen. Actually, I'm going to go down a little bit. So I'll let you copy it, pause it right now if you need to copy it down, or you need to copy it down, so make sure you pause. And we're back. So the last part of today is that I'm going to ask you to do an exit ticket because we haven't done those since we've been out of school. So you're going to copy this exit ticket and solve in your math notebook. Ask parents to take a picture of it and send it to my phone number. Your parents should have my phone number. If you're Miss Delgado's class and you know your mom or your parent knows her phone number, send it to her. And again, if you're in Mrs. Alonso's class and your parents know her phone number, please send it to Mrs. Alonso. If you're in my class, have your parents send it to me so I can just easily go through our students' answers. So the math, our problem today, our story problem is about Ariel, Nova, and Rocky. So Ariel, Nova, and Rocky enjoy eating their Minties treats. Each dog wolfs down 26 treats in 1 week. How many treats do all 3 dogs eat in the span of a week? So you're going to write that down in your math notebook, and you're going to use an area model and the distributive property to solve for that story problem. And you're going to send a picture to my phone or Mrs. Alonso's or Ms. Delgado's if possible. And then for extra practice, I want you to complete page 231 in your Bridges workbook. I hope to hear from all of you guys because I've only heard from a few. I know it's been probably hard for you to use the computer or your parents' phone to do these problems or to do the videos. Just try your best. That's all we really want. And I hope everybody's doing really well. See you guys in the next video. Bye.